Hi everyone, this is going to be a slightly shorter one of these HSC revision videos as we're going through practicalities of measurement. This is where we're talking about the percentage error and all that kind of stuff. So let's just quickly go through these. So we should review the different measurements and being able to convert between common uses of measurements, say kilometers to meters, liters to milliliters, all that kind of stuff. They're all based on the metric system, so it's all just multiplying by 10 or 100 or 1,000 or something like that. Key ones to remember, like kilo always means 1,000, etc. Then we need to talk about, calculate the absolute error, and then the absolute error is half the precision, and then all these other things, the upper bound and the lower bound. The main thing that I think that comes up is the percentage error is the absolute error divided by the measurement and then times it by 100. And that's not on the reference sheet, so make sure that that's a common one. So you get the absolute error, not the limit of reading. Absolute error divided by the measurement that you had times by 100. And then also where it says times by 100%, you don't actually put that 100%, the percentage sign in your calculator, because if you do, it's not going to do anything. So you times it by 100, and then whatever that answer is, that's what you write is with your answer with a percentage sign at the end. And then just knowing all these different things, and then also being able to use standard form. Standard form, just another word for scientific notation. So going through these, talking about limit of reading, our absolute error is a half times the precision. Now the precision is the limit of reading. So like if you got it in the question saying it's measured to the nearest 10 centimeters, your limit of reading is 10 centimeters, and that means your absolute error would be half of that, so 5 centimeters. So whatever it's saying that was measured to, that's your precision. And then your upper bound is you get your measurement and you add that absolute error, and your lower bound is you subtract that absolute error. So just take note that the only thing that's relevant to this that's not on the reference sheet is this, and that's also probably like the most important part you need to know. And then just looking at like its frequency, I've noticed that typically you ask in the HSC one of these questions every year. It's probably going to be in the multiple choice section, and it's probably going to be something about percentage error. So just make the main things you need to know is how you find the precision, how you find the absolute error, and then how you find the percentage error. Alright, so with that said, let's just jump into a couple of past HSC questions. So first one, 2008 question 23B. Of course, I'd suggest you pause the video, have an attempt of it yourself before watching the solution. So what is the capacity of a bottle is measured as 1.25 liters, correct to the nearest 10 milliliters. So that's important. That's telling us the precision or the limit of reading. So what is the percentage error of this measurement? Well, we have our precision is equal to 10 milliliters. So therefore the max error is 5 milliliters, because it's just half of that. So whatever your precision is, you half it for your max error. Now the other thing, before we go any further, we need to find the percentage error. So therefore percentage error is going to be that max error, so 5, over the measurement that we have, which is 1.25 liters. Now the key thing to this to remember is this is in milliliters and this is in liters. So of course we need to convert them so they're in the same unit as well. So here I'm just going to convert this to be 1,250 milliliters. Obviously just timesing that by 1,000. So I'm going to do 1250, and then we're going to times that by 100, and that's going to give me 0.4%. So that's a percentage error. Again, making sure that when you put this into your calculator, don't do times 100%. You just do times 100, and this gave me 0.4, so that's 0.4%. All right. So that's that. And what this tells us is that this measurement can be 0.4% off what the actual perfect measurement is. Going to this next question. Pretty similar to start us off. So a rectangular wooden chopping board is advertised as being 17 centimeters by 25 centimeters, with each side measured to be to the nearest centimeter. So we first want to calculate the percentage error. So we see that it's measured to the nearest centimeter. So our precision is 1 centimeter. So therefore the max error is 0.5 centimeters. Now that we have 0.5 centimeters, we need to find the percentage error of the longer side. So it's obviously the 25 centimeters. So therefore, percentage error equals 0.5 over 25. And again, we'll just times that by 100. And that's going to give me 2%. So we found that. And now this second bit, and the reason why I chose this question is it's kind of it's not as obvious as it might initially seem. What we want to do is between what lower and upper limit does the actual area of the top of the chopping board lie? Now, what we don't want to do, like here we have the area of this would just be 17 times 25. What we don't want to do is find that area, so 17 times 25 equals whatever that is, and then do this max error percentage thing. Instead, what we want to do is we want to find the dimensions, the lower bound of the dimensions, and then multiply those. So what I mean by that is the lower limit area, that's going to equal, so remembering that these lower bounds or lower limits, the lower limit is the measurement minus the absolute error or the max error. Okay, so in this case, it's going to be 17 minus 0.5. So we get 16.5. And then similarly with this, we're going to do 25 minus 0.5. So 24.5. And when we put that into our calculator, we have 404.25 centimeters squared. So what I'm saying here is I don't want to find the area and then do the limit change and all that, the upper and lower bounds. You have to do it the other way around. We need to first find the lower bound of each dimension and find the area based on that. And then similarly for the upper bound, upper limit or upper bound area, it's 17.5 times 25.5. 17.5 times 25.5, and that's 446.25 centimeters squared. And then we have that as well. So, and then that's the answer. So between between these two bounds is the area. Okay. So going on to this next page, and it's just 3 multiple choice questions. And as you can see, this is question 1, question 3, question 5. So they're not ever really going to be super tricky ones. This first one's on scientific notation, or in the new syllabus, it will be referred to as standard form. I guess it could still be referred to as both. So remember, scientific notation, the first thing we want to do is move the decimal point so it's after the first non-zero digit. So I want to put the decimal point after 3. So we're going to count we don't count how many zeros, we're counting how many times we're going to move that decimal point. So we've got a decimal point here, 1, 2, 3, 4, 5, 6, 7. All right. So we know it's going to be to the power of 7, but we actually know it's going to be to the power of -7 because it goes to the right. Remember, whenever you're doing this scientific notation or standard form, when you move the decimal point to the right, it's going to be negative. If I was moving it to the left, it'll be positive. So the answer is clearly B, because it's the only one with -7. Going into this one, what is the value of K correct? Oh, I should mention here, if you're not sure, like what you can always do with these kind of scientific notation questions, just to double check, put that into your calculator. 3.26 times 10 to the power of -7, it should equal this again. Okay. Anyway, back to this. So what is the value of K correct to 3 significant figures with these things? So all we're just going to do is put this into your calculator. Note that this is saying F times T cubed. So what we're not saying is do F times T and then cube it. It's saying do T cubed, then multiply that by F at the end. So when you put that into your calculator, you're going to get K equals 1.827629 ... whatever. And then, so yeah, just 5 times that cubed. You get that. And now we want to round it to 3 sig figs. So starting at the first non-zero number, going across 3, and then round. So it'll be 1.83 because the 2 will increase because the number after that is 7. So it's not that. That would be 3... that would be 3 decimal places. That's just rounded incorrectly, and that's just rounded incorrectly. So we're not only just chopping off all these things, but we need to make sure we're rounding as well. So it's 1.83. And then this last question here, again, it's a another percentage error question, but it says correct to 1 decimal place. Okay? So when it says correct to 1 decimal place, that means the precision is 0.1 centimeters. The reason why that is to 1 decimal place, and then so it's like it's like the increments are going to be 0.1. So that means my max error, or the absolute error, or whatever you want to call it, it's going to be half of that, so 0.05. Don't do 0.5, just do 0.1 divided by 2 or whatever, and you'll get 0.05 centimeters. And now percentage error, so we're just going to do 0.05 over 16, times it by 100, and you're going to get 0.3125%. All right. Again, just remembering, make sure you are multiplying it by 100, not by 100%, because otherwise, if you multiply by 100%, that's essentially just multiplying by 1. Anyway, like I said, it's just a quick one for this. Hopefully it's been useful, and if you have any more questions, be sure to ask. Thank you.